A plain cardboard box moves down a fast conveyor track inside a giant distribution facility. It travels at 15 miles per hour through the dim overhead light of the building. There are no human workers standing near this long section of the track to read the destination label. Yet, in less than 1 single second, the system knows exactly where this package must go among tens of thousands of potential exit points. The box passes through a bright scanning tunnel filled with glowing red laser beams. Laser barcode scanning reads the small black lines printed on the shipping label from 5 different angles at once. The red light flashes in a fraction of a millisecond as the package glides along the belt. Even if the paper label is scratched or wrinkled, the high-speed scanner still captures every line without slowing the line down. That fast laser scan turns into a small string of digital numbers that shoots across high-speed network cables. Inside a nearby server room, a central computer compares the incoming code against a massive database of active shipping orders. The software matches the package identification number with a specific exit chute down the line. All of this data processing finishes before the box travels even 2 inches further down the fast track. Decades ago, large shipping centers could not move packages at this incredible rate of speed. Old sorting hubs relied on human workers who read address labels by hand and placed items onto moving wooden carts. Later automated systems used simple metal arms that pushed boxes off the side of the main belt. These hard mechanical arms often crushed fragile cardboard boxes or caused huge pileups when items arrived too close together. To fix those constant physical jams, mechanical engineers designed the crossbelt sorter. This machine does not use harsh pusher arms or spinning metal wheels to force packages off the main line. Instead, the sorter consists of a long chain of individual motorized carts linked together on a continuous steel track. Each single cart carries its own tiny conveyor belt mounted right on top of its strong metal frame. Hundreds of these small carts form a continuous moving loop through the massive concrete building. They zip along the metal track like a fast train that never comes to a complete stop. The main track keeps moving forward at a steady speed day and night without interruption. Because each cart holds its own independent belt, every package sits safely on its own moving island during the entire journey through the facility. On the main floor below, human workers load large piles of incoming parcels onto long feeder belts. Their job is simply to keep a steady flow of goods moving smoothly onto the primary sorting track. They do not need to check destination zip codes or organize boxes by shape or size. The human touch is limited to the start of the line, leaving the complex routing decisions entirely to the fast machine. Tight logistics synchronization makes this whole fast system work without dangerous mechanical errors. The central computer tracks the exact physical position of every cart on the track down to the millimeter. It knows which cart holds which package, how fast the cart is moving, and how many feet remain before reaching the destination exit. The digital map inside the central computer moves in perfect step with the physical metal track. When the moving cart reaches its assigned chute, the high-speed diverter action begins instantly. The main cart does not slow down or stop moving forward along the continuous track loop. Instead, the tiny belt built directly into the cart bed turns on and spins sideways. This physical belt ejection slides the package smoothly off the side of the moving cart and right down the designated target slide. Timing is absolutely everything during this fast sideways physical handoff. If the small belt turns on just 5 milliseconds too late, the parcel will slam hard into the heavy metal divider wall between 2 exit chutes. If it fires too early, the box drops down the wrong opening and ends up in the wrong city. Perfect physical alignment at high speed prevents costly package destruction and lost shipping time. Arrays of small optical sensors mounted along the steel track constantly check the exact position of each box. These infrared beams watch the precise spot where the package rests on the cart bed. If a heavy box shifts slightly during a sharp turn, The sensor notices the small movement right away. The central control system adjusts the activation timing of the tiny crossbelt to match the updated position. A single high-speed crossbelt sorter can handle over 40,000 packages in just 1 hour. That means more than 11 parcels are scanned, tracked, and ejected into their proper shipping lanes every single second of the day. The sheer volume of goods flowing through the facility looks like a fast river of moving cardboard. The system processes a massive amount of freight without a single human voice calling out directions. The historic switch from old pushing arms to smooth crossbelt carts changed the global shipping industry forever. Fragile items like computer screens, glass bottles, and soft clothing can now move through automated sorting facilities without getting torn or smashed. By using a gentle sideways rolling motion instead of a hard physical impact, the machinery keeps delicate package contents safe while maintaining extreme operational speed. Modern digital scans do far more than just read flat printed barcodes today. Advanced camera arrays build complete three-dimensional models of every box as it enters the scanner tunnel. The central software measures the height, width, and length of the parcel in real time. It uses these precise dimensions to verify that the item will fit safely down the exit chute without jamming the physical slide. High above the noisy warehouse floor, facility operators sit in a quiet control room surrounded by digital monitoring screens. Bright colored lines on their computer monitors display the live health of every cart, motor, and sensor on the line. If a tiny belt motor fails or an optical sensor gets dusty, the system alerts the maintenance team before a serious mechanical breakdown can stop the workflow. The continuous track itself is powered by advanced linear induction motors along the frame. These magnetic drives push the heavy chain of carts forward without using oily gears, rubber belts, or noisy metal chains. The lack of direct mechanical contact drastically reduces physical wear and tear on the heavy machinery. It also keeps the giant sorting hall surprisingly quiet, allowing workers below to communicate easily. During busy holiday shopping seasons, these automated routing systems operate without stopping for weeks at a time. Millions of people order gifts online, expecting their packages to arrive at their front doors in a day or two. The crossbelt sorter carries the immense weight of that global demand on its steel tracks, processing endless rows of boxes with unyielding mechanical reliability and speed. As the small belt ejects a package, natural gravity takes over on the slick metal exit chute. The parcel glides down the angled slide toward a waiting canvas bag or heavy wooden shipping pallet. At the bottom of the slide, a logistics worker scans the container tag and loads the gathered items into a waiting delivery truck destined for a specific neighborhood street. If a barcode label is badly damaged or covered by heavy dirt, the system triggers a smart recovery loop. Instead of stopping the main line, the cart keeps its package and makes another full lap around the fast track. Secondary camera sensors try to reread the label from different angles. If those secondary scans fail too, the sorter gently ejects the parcel into a special lane for human inspection. Most people who receive a box on their doorstep never think about how it arrived so fast. They see the address label on top, but they do not see the complex dance of lasers, computer networks, and moving belts that guided it through the night. The seamless delivery process feels simple on the outside, but it rests on a deep foundation of intense mechanical engineering and rapid calculation. Next-generation logistics hubs are pushing this automated sorting speed even further with smarter artificial intelligence. Future sorters will use real-time video analysis to identify unlabeled packages and adjust individual cart speeds on the fly. These technological upgrades will make sorting loops even faster, allowing distribution facilities to handle millions of extra boxes without expanding their physical building size. Behind the simple act of online shopping stands a vast mechanical engine working in total synchronization. High-speed sorters route packages quickly by bridging the gap between digital scans and physical belt ejection. From the quick flash of a laser beam to the precise sideways roll of a crossbelt cart, This silent infrastructure keeps the modern global economy connected and moving forward without stopping.